Okay. Section 11.2, linear functions. So information about functions. The definition of a function, which is something that you, okay, need to have in your brain. You're going to use it a ton next year in algebra. So it's a relation with each input has only one output. So definition of what something is. Then we've got some examples of functions. So example 1, it's got a list of 3 points, 2, 5, negative 3, 7, and 1, 5. When you're looking at a list of points, the x's or the y's rule? Who remembers? The x's or the y's are in charge? The x's. Okay, yeah, 50-50 chance of getting that right. So the x's are in charge. So it says each input, the inputs are your x's, has only one output. Your outputs are your y's. So the x's cannot be repeated in order for it to be a function. So we have 2, negative 3, and 1. Doesn't matter what the y's are. Only the x's, okay, for a function. So this is definitely a function. We've got another example, and we've got, again, just look at the x's. Negative 5, 4, and 4. That one's not a function, right? Okay, because what's repeated? 4. Okay? So right there, not a function. So when you're given a list of points, the only thing you need to be concerned with is the x's. The y's can be anything they want. Then, what if you're given a graph and you're asked, is it a function? So it says a relation is a function if there are no vertical lines that intersect the graph at more than one point. So the vertical line cut. Vertical, up and down. Look at your graph. So we look at this curve here. Can I draw a vertical line that is going to cross this graph in more than one location?
Yes.
Vertical line?
No.
Okay. A vertical, up and down. Can I find a vertical line that I could draw in here that's going to touch the graph or intersect the graph in more than one location?
No.
Okay, that's just one. I could draw one over here. I could draw it over here. I'm only intersecting in one location, so therefore that is a function. But look at the curve in example 2. Can I draw a vertical line that's going to intersect in more than one place?
Yes.
Okay. The minute you find that vertical line where it's going to intersect more than once, done. Not a function. Okay, you say that it fails the vertical line test. Okay. If it is a function and only intersects the graph once, then you say that it passes the vertical line test. Okay. So information about our function, our linear function. Format. Y equals mx plus b. That one's really easy to say, really easy to remember. Okay. There is another one that we spent a lot of time with earlier this year. So this one is the slope-intercept form of a function. Slope-intercept. Okay. The one we spent a lot of time with was y minus y1 equals m times the quantity x minus x1. Who remembers what that one's called? That
Point slope.
yeah, point slope. x1, y1, there's our point, and then m is the slope. So this one is the point slope form of a line. Both of them are acceptable. Okay, you'll use both of them. It just depends on what situation you're given as to which one is most helpful. So slope. Slope is the m. I don't know why it's m. but it is, okay? And it's a rate. So we know slope is m, we know that it's rise over run, we know that it's change in y over change in x. Remember that little triangle, that's the Greek letter delta? And that means change. And we tend to use this formula a ton. Y2 minus y1 over x2 minus x1. Notice there's equal signs in between all of those because they're all the same thing, they're just different versions of it. Whatever one works for you is totally fine. Okay, we tend to use the one that I highlighted in blue the most. And on the y-intercept is represented by b. Again, I don't know why they chose B, but some mathematicians thought that was a good idea. Right. The y-intercept is B, and it indicates the initial value when x is 0. It's our starting point. Our starting point. A couple examples that we can do. So it says you join a gym that charges $50 to join and $25 a month. So $50 to join and $25 a month. Which one's the slope and which one's the y-intercept?
Slopes, $25, it says per month.
Love it. Yep. Sure thing. Slope is 25 because it says per month. Okay, that's that rate. And the y-intercept is that one-time fee is the $50. So if I'm given the slope and the y-intercept, which one of my forms am I going to use? Slope-intercept. Okay, don't make it difficult. If they give you the slope and the intercept, use y equals mx plus b. So who can write the equation for me? There's the formula. Sophia. Think about that again.
25.
You got it. All right, example 2. You join a gym that charges $25 per month. You know you pay $100 after 2 months. What kind of info are we given in this problem? What's the $25 per month? So, but then $100 after 2 months. $100 after 2 months. What is the 100 and what is the 2? What is that? 25 is the slope. What's the 100 and what's the 2? Is it a y-intercept? What is it?
The 100 is the y-intercept.
Close. 100 is not the y-intercept. The 100 is it a y or is it an x? The y. 100 is the y, and then what's the 2? The x. So what did they just give us? They gave us a slope and they gave us a point. Okay? A point. So we're going to use point slope. Okay? Time, any sort of time is always your x, is always your independent variable. Okay? So 200 is our point, and yes, we're going to use point slope form. Who can substitute into that one for me? Got it all here. Here's our x1, there's our y1. Who can substitute that? Go ahead, Amy.
Y minus 100 equals 25. In parentheses, x minus 2.
Perfect. Now what should I do with the distribute? 25x minus 50. Then what? What should I do now? If I distributed, what should be my next step? Add 100. 25x plus 50. So what did we just do? We solved it for y, but now what form is it in? Which form is it in from up here, from up above? Slope intercept form. Okay. So that's the beauty of that, okay? You could leave it just like this. That's okay. That's acceptable. Or you could simplify and solve for y. That's okay too.
Not clarifying, but so it's the, I know they're the same answer, but since 50 is the joining, the 125 times 200 plus 50. So I think you're just 100.
Yes, yeah, absolutely. Yeah, that's another way of getting to
Okay.
it. Definitely. Okay? All right. So, last one. It says you go to a gym that charges $100 for 2 months and $200 every 6 months. Do they give us the slope here? Do they give us their rate per month? They give us 2 points. Okay, so we've got 2 points. So what are my 2 points? I said time is always your x. Can someone list them as 2 points? Come on, somebody other than Aiden, and Zach, and Sophia, and Emma. Come on, guys. Let's put it as 2 points. I just said the time is your x. Time. Anthony, what's the first point?
So 2 and 100.
Perfect.
And the second one is 6 and 200.
Awesome. So if I've got 2 points, what am I going to have to find? The slope. I got to find the slope. Right. So if I label it x1, y1, x2, y2, I'm going to find my slope first. So I've got to do some substituting here. I'm going to substitute into that slope formula. 200 minus 100 over 6 minus 2. So what does that simplify to? Which is
25.
25. Look at that. So now we've got the slope, and we've got a point, right? We've got 2 points actually. Does it matter which point we work with? No. Doesn't matter. Once I have the slope, I can pick either one of these to work with. So what form should I use? Slope intercept or point slope? Do I have the intercept right now? Do I have the y-intercept? I don't. So use point slope. Go with what you have. Joey, can you talk real loud and substitute into that for me? Okay, so I've got my point
Okay.
up there and my slope.
Y minus,
I just didn't hear you.
y minus 100.
Yeah.
Equals 25. All parentheses. 2.
We want to go the x first, and then the x1 is going to be your 2.
Oh, that's right.
Close your parentheses. Okay. So you can, yep, you can leave it like that, or go ahead, Joey. You were starting to say? Was it you? I think you said it. Who said it?
Maybe.
Maybe you. I said distribute. Okay. So y minus 100 equals 25x minus 50. Oops, forgot my x. Add 100. Wow. Look at that. Same equation. Okay? So it's the same situation. I just gave it to you 3 different ways. Okay? And you were able to come up with the equation. Okay? Alright, flip it. Almost done. 3 different linear functions below are represented in 3 different ways. First way. What is this called here in Roman numeral number 1? Not a trick question, friends. The teacher, yeah, or table, okay?
Oh.
What's Roman numeral number 2 called? You got it. What's Roman numeral number 3 called? Equation. Oh, this has 3 different ways. This is 4 different ways. Okay, so we have an equation. And then what about in Roman numeral number 4? Words. Yep, words are that math sentence. Okay, words. All right, it says which function has the greatest rate of change? Justify your answer. Rate of change. What am I asking there? What is rate of change? Slope. Okay. How do I find slope in number 2? Roman numeral number 2 in the graph. Ashley. I could go even easier on yourself. Ashley's talking about find 2 points, use the equation. We got a graph. Make your life easy. Say it.
Rise over run.
Yeah. No, rise over run. Okay, still gonna find 2 points. So I think this is good. My old eyes have to back up. Take those 2 points and then just rise over run. How many are we rising? How many are we running? 3 over 2. So, rate of change is 3 over 2, or 1.5, right? Okay. Please don't use a mixed number. That's elementary school. Number 3. How do I find the slope in number 3? Y equals mx plus b. Okay. Emma, you are on a roll today.
I am.
You are. Y equals mx plus b in number 3. What am I doing? What's my first step? I haven't told you what to do. Sophia. I can't divide by 3 because that's the x. I gotta get y by itself. Who's saying it? Subtract 3. Then what? I get y alone. Y equals mx plus b. Grant. Divide everything by 2. What's the rate of change for this one? Careful. Just eliminate one thing that you said there, Zach.
-3.
No. What's the slope? It's what?
3 over 2.
Just 3 over 2. Remember, it's just the m, it's just the coefficient. So, rate of change here is 3 over 2. That's probably not good to highlight with that. Maybe yellow. 3 over 2. 3 over 2. Let's convert that one. Number 4. Y is, what does is translate into? Is in math. Equals. Equals. Nice. Well, y is 4 less than, oh, careful, 4 less than a number. Oh, x minus 4. Less than means you have to switch the order. X minus 4. So what's the rate of change in that equation? Y equals x minus 4. Rate of change. Slope. What's the slope in that equation? 1. Always the number, never the letter. Okay? So the rate of change in that one, I'm going to change colors there, is 1. Lots of work for this one. What am I going to do with number 1? Why did I skip over that one? How am I going to find the rate of change from the teacher? Anyone other than Zach and Sophia? And Emma and Avery. And Grant. Jenna.
You have to find the difference between that and
Yeah. Okay. essentially we're using y2 minus y1 over x2 minus x1. But because it's in our nice little chart here, okay, you guys like to do this. Whoops. Find the difference. Okay. So how do I go from -9 to 3? What am I doing? From -9 in the number line all the way up to 3 is a difference of what? 12. What about from 3 to 9? Okay, 6. All right, but what's going on with the x's? From -3 to 3? 6. It's a plus 6. And 3 to 6? 3. That's a plus 3. So what do I do with those numbers? To find my rate of change. Change in y over change in the x. Think about that. Change in the y over change in the x. So what's happening with the changes in the y's over the changes in the x's there? Change in y. What's the change in the y? It's 12 divided by 6. What's 12 divided by 6? 2. What about this? 6 divided by 3 is 2. So what's the rate of change for the table? 2. Okay? Now, can you finally answer our question? Which function has the greatest rate of change? After all that work, which one is the greatest rate of change? 2, 3 halves, or 1? 2. Right? All the work was our justifying. Justifying means show the math. Okay? We did. Okay? So, Roman numeral number 1, greatest rate of change. Does any pair of functions have the same rate of change? Which two pairs? 2 and 3. 2 and 3. Again, justify, show the math we did.